All right, so on Wednesday we learned how to convert from moles of one thing into moles of something else. Today we're going to add one extra step into that. So we're going to go from moles of something into molecules or particles of something else. So we're just adding one step into what we did, one additional step into what we learned on Wednesday. So there's a new equation for this one. And we are going, like I said, from mole of our given to mole of our wanted, and then into particles of our wanted. So there is a new equation that we're going to use. So we're going to take our number of moles given, and we're going to convert that into moles of our wanted by using our coefficients. So we're going to multiply it times our coefficient of our wanted over our coefficient of our given. Remember that we get these coefficients from a balanced chemical equation. Okay, so these come from a balanced chemical equation. And then the last thing that we're going to do is we're going to try to figure out how many particles we have. So we're going to be using Avogadro's number again. So we're going to multiply times 6.02 times 10 to the 23rd particle over 1 mole. So this is kind of our general setup that we're going to be using. Use this one. So our example problem. How many molecules of CO2 are produced from 0.75 moles of propane? And just in case you didn't know, propane is C3H8. And because we're using two different things, you're going to get a chemical equation for this one. So our chemical equation is C3H8 plus 5 oxygen gas combusts and give us 3 carbon dioxide and 4 water. So I'll let you guys get that written down. When we're reading this problem, I guess I should say. We need to figure out first what is our given and what is our wanted. So our given is going to be this 0.75 moles of propane. So that is our given. It wants to know molecules of CO2. So we want molecules of CO2. Okay. So we're going to set up our train tracks. Our given, our moles, our given is going to go in our upper left-hand corner. So we have 0.75 moles of C3H8. Next, we're looking at our mole ratio. So we're trying to convert from moles of propane into moles of carbon dioxide. So we're going to use our balanced chemical equation to do this. Our want is CO2. So we're going to search for CO2 in our balanced equation. And CO2 is right here. We have 3 of them. So our coefficient of our want is going to be 3. So we have 3 moles of CO2. Our given was propane, which is C3H8. So we have to find C3H8 in our balanced chemical equation. It's right here. There's no coefficient in front, so we are just going to assume that that coefficient is 1. So we're going to have 1 mole of propane. With this setup, our moles of propane cancel out. So right now our unit is moles of CO2. We wanted to solve for molecules of CO2, so we have one step left, and that's going from moles into molecules, and we're going to use Avogadro's number to do that. So Avogadro's number is 6.02 times 10 to the 23rd. Our particle is molecules, so that's what we would write down, and we would write that over 1 mole. That way, the word mole cancels out. So in our calculator, we would have 0.75 times 3 times Avogadro's number divided by 1. The unit we're in is molecules of CO2. Okay? When you multiply that out into your handy-dandy calculator, you get an answer of 1.4 times 10 to the 24th. Our unit is molecules, and our molecules are of CO2. So your practice problem, gotta flip my sheet over. How many molecules of NH3 are made from 4 moles of calcium hydroxide? We're working with 2 different substances in this question. We've got NH3 and CaOH2. So you are going to get a balanced chemical equation. All right, there's your balanced chemical equation. You've got ammonium sulfate, calcium hydroxide decomposing into ammonium, calcium sulfate, and water. So go ahead, try to set this question up and try to solve for it. And then in a few moments, we will go through it together. 1. What is my given in this problem? What is my given? Lawson.
4 moles of CaOH2.
Perfect. 4 moles of CaOH2 is my given. For another Deke dollar, what do I want? Jenna.
Molecules of NH3.
Yes, molecules of NH3. Very good. All right, for another Deke dollar, I need to start setting up my train tracks. What goes in my upper left corner of my train tracks? David.
The 4 moles of CaOH2.
Yes, so we've got 4 moles of CaOH2. All right, good. We've got that set. What goes in my the top of my middle train track? Jacob.
The coefficient of what you want.
Exactly, the coefficient of what I want. So I want NH3. So I need to find the coefficient for NH3. For another Deke dollar, what is my coefficient for NH3? Lawson.
2.
2. So NH3 is right here. Coefficient is 2. So we've got 2 mole of NH3. What goes underneath that? David.
The 1 mole of CaOH2.
1 mole of CaOH2. Very good. So our moles of our given, our coefficient for that is 1. So we're going to write 1 mole of CaOH2. All right, so right now we've got our moles of CaOH2 canceling out, and our unit is moles of NH3. What is my last step? What do I need to do next? Miss Crandall.
Put Avogadro's number on top.
Yes, we're going to put Avogadro's number on top, which is 6.02 times 10 to the 23rd molecules. We're going to put that over mole. And next you're just going to multiply. So 4 times 2 times Avogadro's number, or basically 8 times Avogadro's number. And you should have gotten roughly 4.8 times 10 to the 24 molecules of NH3. Is that roughly what we got as our answer? Roughly. Okay. Thumbs up, thumbs middle, thumbs down. How do we feel about this? Okay. So